Hello, and welcome to this session focusing on cognitive health. Before we begin, I'd like to remind our audience that there will be a Q&A box located in the top right corner of the platform where you can submit any questions you have for our speakers. These will be answered time permitting at the end of the presentation. Our first speaker joining us is Andrew Scully, the Principal Director at Medivate Consulting. Andrew works closely with industry to translate science into evidence-based benefits to brain health. In this session, Andrew will focus on bioactives for the brain. What's the evidence and how can we use it? Andrew, I'll turn things over to you.
Thank you very much, AJ. I hope somebody can signal if there are any problems, but I hope you can hear me. Yes, and thank you so much for the invitation. It's a great privilege to be here. I have been in person a couple of times. I know it's an excellent conference, so thank you very much for that. So I'm going to be talking a little bit about some of the work that I've done historically, but also more recently with Medivate Consulting. Before I start, I should probably just give my disclosures. So yeah, there's quite a few companies that I've worked with, probably some people present at the conference today, as well as a lot of government funding. And I also should disclose that I'm Chief Scientific Officer at Arepa Nootropics and Delica Therapeutics. If you're interested in any of those two things, you can find me on my personal website, but that's not what I'm here to talk about. I'm here to talk about how we can try and protect the brain and make the brain and cognitive function occur, really just to improve it and enhance and optimize what is loosely referred to as brain health. By brain health, I mean mental states, mental performance, cognition, mood, well-being, etc. But all of this, of course, is underpinned by changes in the brain and neural tissue. And so if we look at, I think, what many people would consider the worst case scenario, what we can see is that as we hit our 60s, 70s, 80s, that the probability of contracting Alzheimer's disease increases. This is actually the very first patient zero, if you like, of Alzheimer's disease. The first patient to be diagnosed by Alzheimer with a disease we now call Alzheimer's disease, or dementia, characterized by gross impairment in cognition and also a huge emotional dimension, which is sometimes overlooked. And I think it's true to say that the consensus is that these current pharmaceutical treatments for Alzheimer's disease and other dementias have really failed spectacularly for a number of reasons, which I can't go into here, but this approach just hasn't worked. And you can see that the so-called blockbuster drugs for brain health are all pretty old, at least 2 or 3 decades old. And part of the reason is that probably by the time people are diagnosed with Alzheimer's, it's too late. And there's increasing evidence that preventions and the kind of interventions which can protect the brain from not just Alzheimer's disease, but cognitive decline in general, are better if they are initiated much earlier in life. There's also a really interesting kind of transitional condition or phenotype called subjective memory impairment, sometimes these days called subjective cognitive decline, which is when people are at risk of cognitive decline. And what's really interesting about this critical condition or this critical state is that not everyone goes on to get Alzheimer's disease. The reason is that the genetic factor for contributing to things like dementia and cognitive aging probably account for about, at most 25-30% of the sort of variance in the disorder. And there's increasing evidence that there are important lifestyle factors which are involved in cognitive decline and dementia. And if we look at it, this is the idea that there are a number of components of brain and cognitive aging. Pharmaceuticals aim at doing one thing, propping up the chemical transmitters of the brain. And yet we know that there are a huge number of other influences on cognitive function, from glycemic control through blood flow, cardiovascular function, oxidative stress and inflammation, hormonal activity, psychological stress, and of course the microbiome. And all of these are realistic targets for the kind of products which are developed by many of the companies here, what I broadly call nutra intervention. So that includes nutrition, but also nutraceuticals, botanicals, herbal extracts, and other kinds of sort of naturally derived interventions. So that's, in a sense, the extreme. What's important, I think, is to remember that most of us are pretty healthy for most of our lives. That is, we are in this 90%. We're neither kind of in a clinical population, and I mean, we're all exceptional, but we're not exceptional in terms of outperforming the population. And so is it possible that shifting within this 90% area here can benefit the brain health of populations? And the answer is yes. We can shift. We can shift mood, cognition, and well-being within this 90% area. And myself and my colleagues at Metivate, Professor Constow as well, have spent the best part of the last 25, 30 years examining this phenomenon, using natural products to try and optimize performance. And this sort of shifting here within this 90% has a couple of consequences. One thing it does is it optimizes mental function and well-being on a day-to-day basis. That is, you can be your best self every day, or you can mitigate against a night of poor sleep or feeling stressed because of life events. And it also reduces the risk of future cognitive decline and dementia. And so how do we do this? Well, it's a couple of approaches through a combination of clinical trials. So clinical trials simply say, does this work? Does this intervention work? And then we use the data from these clinical trials to generate hypotheses, to ask, why does this work? And then if we find targets which are important for cognitive function, we can go on to think of new ways of modifying the targets with these sort of nutra type of interventions. And so doing that, we look at biomarkers, we look at neuroimaging, which I'll talk a little bit about later in the talk. And the kind of things that we look at in this context are whole lifestyle factors like diet, exercise, botanicals, so botanical extracts, isolated botanicals, the flavonoids, terpenoids, and other compounds within plants, and other things, other nutrients and bioactive nutrients. And I think it's also worth saying that even within a product, as this audience probably knows very well, it's important that there are critical differences between different extracts. And the other partner in Metivate Consulting, Nigel Pollard, is an expert in that source to benefit pipeline. And of course, the ultimate aim is to translate the findings from this science into things like government recommendations, implementation, but adoption by industry. We're very keen to help people with commercialization, but all of this is based on evidence-based health claims. And also, I'll talk a little bit later about some endeavors in public dissemination and education. So what is cognition? Well, there are many, many different ways of carving up cognition, various taxonomies, if you like. But one simple one, which I think has a lot of utility, is this very simple model where we've got attention, working memory, and secondary memory in the center here. And then we have executive function and mood. And Metivate will be running workshops over the coming months, looking at this in a lot of detail. If people are interested in that, I'll give you details. But for the purpose of this talk, I'll be focusing on a few aspects of that. But first of all, it's worth noting that we can measure these things. We can measure attention, working memory, secondary memory, mood, and executive function. This is just some tasks that I use, but I use many more different ways of capturing these effects than those listed here. I'm going to show you a couple of examples of these. The important thing is that there are hundreds of cognitive tests which measure aspects of these processes. Hundreds. And of course, if you don't have subject expertise here, it's very easy to design an experiment which you think is going to capture these effects, but it's really important to design experiments and clinical trials and other ways of capturing the signal from nutra types of interventions. Just to sort of take a step back and say, well, how does this work in everyday cognition? I think one of the ways of thinking about this is just a simple kind of idea of an everyday activity, or an activity that we're beginning to refamiliarize ourselves with, which is the idea of, let's say something like checking into a hotel. So you check into a hotel, you go to the reception desk and you use attention. Attention in this case is selective attention. You're being bombarded by millions of stimuli every second, and you have to filter out the ones which are irrelevant. And that's one aspect of attention. There are at least 4 other aspects of attention, which I could spend an hour talking about each one. But that's attention. The person on reception gives you your key card. You go up in the lift and you think, well, okay, I'm going to have to remember that later. I'll just turn that over in my mind over and over again. So this is using working memory, where you're rehearsing the number which you know you're going to have to remember later. So that's working memory, where you're actually consciously operating on the information. And I'm going to talk a lot about working memory over the next 15 or so minutes. Then later on, you go out for your meal, you come back, get back to the hotel, think, okay, which room am I in? And you recall the room, and you recall the one that you'd rehearsed in working memory earlier, even though you may have remembered in the past, you may have remembered tens, hundreds of different hotel rooms. You remember the one that you'd rehearsed earlier. And when you recall your room there, you're using something called secondary memory. So that's involved in things like names to faces, putting in names to faces, remembering somebody's birthday, just remembering information, remembering where you parked the car in the morning. And it kind of breaks down when you get this tip of the tongue effect, where somebody says, oh, who's the actor who played James Bond, one before last? And eventually you'll retrieve that information, but it'll take a while. So you're using secondary memory there. Then we've got executive function, which is involved in things like multitasking, in planning, in inhibiting inappropriate responses, in just sort of controlling a lot of these other things. So working memory, I'm going to talk about that next. And like I say, I think just to emphasize that Metivate, with some of our partners, will be providing some workshops focusing very much on how we measure these different aspects of cognition, and also mood and well-being. So working memory, if you're given a new bank card and you remember the PIN, you're using working memory as you rehearse that 4-digit PIN over and over again. It breaks down where I'm sure we've all had this experience, where you walk into a room at the other side of the house and you think, what did I come in here for? And that is working memory sort of not quite working. Or when you pick up your phone, you're going to call somebody, and then you think, who was I going to call? Or you open up your email because you're going to email somebody, and then instead of doing that, you end up like looking at some other emails and getting distracted, going online. So that when that breaks down, that's working memory. When you say start to dial a number on your phone and then forget who you're going to phone. Okay, so here we go. what is working memory? I'm going to talk a little bit more about it, but one thing is it's a really crucial aspect to cognition, to mental performance. So again, just to emphasize that there are huge individual differences in working memory performance and how it changes over time. So here is a graph plotting working memory performance in people aged about 60 here to 95 here, and you can look at their performance. And what you can see is there's huge variability. So, but certainly, although there's a kind of overall downward trajectory, it's not just a straightforward linear relationship between age and working memory performance. So here, for example, on the left, if you can see my cursor, there's an individual who started at about 70 and over the 6 years declined a lot. Whereas here we've got a 90-year-old whose working memory performance starts well and is pretty much maintained over the next sort of 6 years. So this is really, this really emphasizes there are individual differences in performance which seem to be due to lifestyle factors. Those are the two I was talking about. And so it is, the relatively small amount of information you can hold in mind. That's a very formal definition, but actually people often talk about working memory as being a bit like your conscious state. Okay, here's another, I think, nice example. So we're all really familiar with the idea more recently of this idea of two-factor authentication. So two-factor authentication, you're on an app. This is our Metivate Cognition, Mood and Metivate Wellbeing Index app here. And when you open up apps like this, you're asked to enter a code that's sent to your phone number. And then if you've only got your phone on you, if you think, I'll just assess myself while I'm at the supermarket or something, I've just got my phone. So then you switch into the authentication code here, and then you have to remember this 6-digit number and then go back to the app you're using. And it's here when you are remembering this number and switching back to the original app here that you're really working your working memory hard. So it's that kind of maintaining that information in mind rather than having it there in front of you where working memory is being taxed. Okay, well, how do we test it in the lab? Well, here's an example where of digit span. So digit span is just, you'll see a series of about 7 numbers. And what I'd like you to do, if you don't mind, is speak them back to me at the end of the 7 numbers. So here they come. Okay, sorry. And then you're speaking them back, and yeah, I'm sure that everybody got 7 out of 7, so that's excellent. And what if I asked you to do it backwards? Of course, you would then have to you'd have to say those numbers backwards, and that's a lot more taxing than the original form of it. The other thing that we do a lot in this area is use computerized testing. So there are some examples of computerized test batteries here. I won't bother going through them. By the way, I'm giving these slides to the organizers so that they'll be distributed afterwards. But these are very important because they capture the speed and accuracy of responses. And that's important because of something called the Sato curve, speed accuracy trade-off. So speed accuracy trade-off means that you can either be very fast but make a lot of errors, or you can be very accurate, so you make few errors, but you're slow. And so it's important that you capture both, because you might say, oh, I might design a test and it says, wow, these people are really getting much more accurate with this nutraceutical intervention. But then if you dig into the data, you can see that the reason that they're doing that is they're much slower. So it's really important to capture both if you can. And here's another test. This is from a battery that was developed at Swinburne University. And in this case, what you do is you're presented with a grid like this, and your task is to remember where the white squares were on the grid. So you're then given a pause of about 2 seconds, and then you have to say yes or no whether that was in the grid or not as the stimuli are presented. And so that's spatial working memory. You have to hold the position in consciousness while during that pause situation. And here's some real data from a multivitamin supplementation study where working memory was part of a big battery. But what you can see here is that the intervention improved working memory. It was faster. What does that mean? Well, this is what happens normally with working memory with age. This is how fast people can respond to a very simple stimulus. So the stars flashed up on the screen. You have to press a button as quickly as possible. And what you can see is the ability to do that slows a little bit with age, between 20 and 85, but not much. Whereas working memory, that very task I just showed you, people get slower and slower with age. This is a time to respond. If we look at the effects of that supplementation, what we can see is if we superimpose it on this age curve here, this is the equivalent of saving about 6.5 years of cognitive aging, which I think most of us would give. And here's another example. I don't want to labor this too much. I think the slides will be very, very clear, but this is just looking at neuroimaging, looking at which areas of the brain light up during working memory. This is the task where you get numbers fired at you very, very rapidly, and you have to respond when there are 3 consecutive even or 3 consecutive odd numbers. It's very taxing on working memory. And you can see that over a number of studies, it lights up, or different tasks which tap into working memory light up this really characteristic network in the brain. This is the network of the brain responsible for all sorts of different types of working memory. And this is some work looking at a B vitamin supplementation, showing that compared with placebo, that this supplementation indeed does increase activation within these areas of the brain. So these are really powerful techniques. And they tell us a lot about things like whether the intervention is actually having an effect on the brain. But those studies are really interesting to understand the mechanisms of cognitive improvement, but they're very expensive, and partly driven by lockdowns. People started looking at online and app-based cognitive testing, including ourselves with our colleagues Cognis. One older example is looking at a very old test battery, looking at, this was the effects of whether children had breakfast or not on cognitive function. And I won't go through the details of these slides, but essentially what we found was that kids who'd had breakfast had better concentration and better memory compared to those who hadn't. So all this demonstrates is that online testing works in a number of populations. I'm actually going to skip through these, like the next couple of slides. I'm sorry, I hate doing that, but it's I think I'm running out of time. And this is just a study looking at mobile phones. So this is mobile phone testing of mood. So this is stress, anxiety, and also physical fatigue over a 16-week intervention, again with a multivitamin, showing this was really sensitive to the effects of the multi. So this is really important because it shows that there is real utility in using apps and wearables to collect data on mood, cognition, and well-being. Here's an example of an app we've developed looking at cognitive performance, mood, sleep, and our own Metavate well-being index. Cognitive testing, looking at how people feel at the moment, and that generates these scores on a number of dimensions, asking about sleep, etc. So we can do some now really sophisticated measures of different aspects of mood and cognition. And this is really important because there are a huge number of substances which are marketed for cognition and mood. And this is our A to Z of cognition and mood ingredients. But the problem is, although there are thousands of products marketed for brain health, very few of them have evidence. And even within this sort of A to Z, the top 100 A to Z, the level of evidence ranges from really high level 1 evidence from a number of clinical trials consistently looking at that, over to other substances which have absolutely no evidence behind them. They're just marketed. And it's really important that we get good science behind these products. And so this is something, this is a sort of advert now. So if you'd like more guidance on this, there are a couple of ways of doing this. One is an ebook, which is available from our website, Motivate Consulting, not .com, it's .consulting. There'll be a clickable link in the PDF that will become available after this. If you use the coupon VitaFoods, you'll get a discount, and also a workshop. So we're going to be presenting a workshop exploring some of the ideas that I've talked about in this talk in a lot more detail, looking at which tasks are sensitive to cognitive enhancement, how to design a clinical trial with a claim in mind, for example, which is very rarely done. And so we're really looking forward to this. And again, there's a few links there you can use. And I think it's really important that we bring the best level of evidence to try and enhance the brain health of our end users. Thank you.
Thank you, Andrew, for joining us today and sharing those key insights on cognitive health. We do have time for one quick question, and that is, how long would it take for a nutritional intervention to show an impact on some of these neurocognitive tests?
Great question. The answer is some occur immediately. So some of the cognitive effects occur acutely. So in the minutes, hours after taking a single dose. Others take longer, sometimes weeks or months, depending on the mechanism which they act on. That slide I showed with all the various mechanisms around neurocognitive aging and neurocognitive function showed, for example, things which affect or protect against inflammation tend to take a bit longer to have an effect, whereas there are other flavonoids, for example, which improve blood flow to the brain within a couple of hours, and they can have a very immediate effect.
Perfect. Well, once again, thank you, Andrew, for joining us. And to our audience, if you have any further questions, feel free to reach out to Andrew directly on the platform after this. Thanks, and we'll see you in the next session.
Thank you.